All right, in this section of the lesson, we're going to take what we have learned about electromagnetic radiation and about matter, and we are going to look at how to interpret the hydrogen spectrum. So our learning target is recognize that the electron in a hydrogen atom can only exist at a few exact energy levels and nowhere in between, and that it can transition between levels when it absorbs or emits a photon having an energy exactly equal to the energy difference. And that energy exactly equals because of the conservation of energy. If the electron loses energy, then the energy of the photon has to be exactly equal to the amount of energy that was lost by the electron. So the hydrogen discharge spectrum, here is the visible part of the hydrogen discharge spectrum. Just got 4 very narrow lines of 4 different colors. This shows more of the hydrogen spectrum, including lines in the infrared and ultraviolet, which we can detect in the lab even though we can't see them. So here are the visible lines. And then at the high energy side, we've got some in the ultraviolet, and in the low side, we've got a bunch in the infrared. What do we see? Very narrow lines. What does a line mean? A line means the energy of the hydrogen atom changed by an amount equal to the energy of those photons. So the energy of a hydrogen atom can only change by a few possible amounts, and these are exact. What does that mean? Bohr said the energy is absorbed by the electron recall a hydrogen atom has only one, and this tells us that electrons are pretty weird. At a small scale, a quantum scale, things do not act like the objects we observe in the macroscopic world. How are electrons weird? To start with, if only certain energy states can occur, only certainly energy changes can occur, then that means that only certain energy levels or states are possible for the electron. So here's a diagram showing different possible levels. The electron can exist here, or here, or here, but it cannot exist in between. The electron simply can't have any other energy than at the levels shown. The energy levels that are allowed for the hydrogen electron are called stationary states. No change can occur within a particular level. The only possible changes are between levels. So stationary because no change while the electron is in that level. Changes from a higher to a lower energy emit photons equal in energy to the difference. These photons make up the emission spectrum that we see. Why are electrons restricted to specific energies? The short answer is that at the quantum level, i.e. the extremely tiny, things behave differently than what we see in the macroscopic world. More specifically, and like photons, electrons act like waves as well as like particles. This is called wave-particle duality. And this is a famous experiment that demonstrated the wave nature of electrons. It relates to interference of light. If 2 light waves line up so that their peaks and troughs are aligned, then what you get is, if this goes away, what you get is a wave that has twice the height, twice the amplitude. If they line up so that their peak, the peak of one is lined up with the trough of the other, and the trough of one is lined up with the crest or peak of the other, then they cancel each other out, and what you get is no wave at all. So when 2 waves, and you can see this if you have 2 sources in water, but when 2 waves pass through a slit, they interfere with each other. And where they line up in phase, you get twice the height, and where they line up out of phase, you get 0, you get flat. And if you place a screen, you get alternating bright, dark, bright, dark, bright, dark. So bright is where the double height wave hits, dark is where they cancel out and you get 0. Okay, all very well. If you do this with an electron, if you do this with electrons and you slow them down so that only one electron is hitting this at a time, if the electron acted fully like a particle, it would go through one slit or the other and hit the screen. And we would see images on the screen from electrons that came through this slit, and image from electrons that came through this slit. But a single electron confronted with two slits like this creates what we call a diffraction pattern like this. So the single electron can diffract itself. It interacts as if it is one wave passing through both slits at the same time, and that demonstrates the wave nature of the electron. So musicians may be aware that only certain overtones occur with any note. When waves are constrained, like an electron in an atom or a sound wave in a musical instrument, only a few specific energies are allowed. If you want to know more about waves and why only certain energies are allowed, I've included a couple of optional videos. The main takeaway: we will continue studying the arrangements of electrons in atoms. The essential point to remember is the learning target for this section in garish hydrogen discharged tube colors. Recognize that the electron in a hydrogen atom can only exist at a few exact energy levels and nowhere in between, and that it can transition between levels when it absorbs or emits a photon having energy exactly equal to the energy difference.